Okay, I got a MIDI controller for the Tesla coil, and this is my case that I 3D printed for it. The controller itself is from Eastern Voltage Research, and as far as the switches and the knobs, I 3D printed those. These are just little extenders. They go over the switch, and so then when you put the cover on the right way, you can then flip the switch on and off, and you can turn the knobs. I made knob extenders for the potentiometers. So let's take a look at the circuit board, and I'll just take those off to get them out of the way. I'm not going to take those off because there's actually a set screw in there. I don't know if you can see it. There's a set screw right there locking it onto the shaft. So those, I could take them off, but I don't want to. So this was a kit. This is the universal MIDI interrupter. Again, from Eastern Voltage Research. It's a kit. It was, I don't remember, 128, I think. 128 bucks? I forget exactly. You can get it with this. I got the fiber optic driver here. There's a couple of different of those you could get. There's a BNC, something else. You could get the deluxe kit that has all of them on it for a little bit money more. For a little bit more. But I only needed that one, so I just got that. And again, you have to assemble the board. This is actually an easy board to assemble. If you're brand new to electronics and soldering boards, if you've soldered together at least one like beginner board, this would be a really good one to go up to. I wouldn't call this a first project board. If you've never soldered a component on, I don't think I would start with this one. It's not difficult, but it is a little bit pricey. So if you screw up, that's again, it's a bit of money. So you might want to practice on a cheaper board. But if you've done soldering before, then this would be the perfect one you could do. It went fairly smoothly, uneventfully. Now, there are a few little issues with the instructions that I will point out here. But overall, I'm very pleased with this. At first glance, I thought it was a little bit too expensive, but, when you consider the work that goes behind it, the development, having the boards printed, getting the pieces together, figuring out the code, programming the microprocessor, so that comes pre-programmed. So there's a lot of work behind the scenes that goes into it. So yeah, it might be a little expensive, but I appreciate the work that went behind providing this for me. Plus, the guy at Eastern Voltage Research, the engineer there, he helped me out a lot, emailing back and forth to get my Tesla coil to work. So I really didn't mind paying the again, I think it was with shipping. I think it was like 140 something with shipping. But it was a nice, easy build, a nice board. Everything went together fine. Just a few things to point out with the instructions. The capacitor here, this is a polarity sensitive capacitor. I don't know if I'm going to be able to get that in there or not. But there's a marking on the side there for negative. And the instructions tell you, the instructions are very clear. The instructions seem like they were written for somebody who's never put a board together before. The instructions tell you very specifically that resistors are not polarity sensitive, so they don't matter. They tell you that the diodes are polarity sensitive, so make sure you put the black stripe on the board. So they're telling you all of that. They're telling you to make sure the notch on the ICs match up to the diagram on the board. But for that capacitor, it tells you that there's a marking for negative, and it says positive is marked on the board, and it's not. Now, it's easy enough to figure out. If you look at the schematic that comes with the kit, you can see that positive goes to that resistor and the voltage regulator. Negative goes to the ground plane on the back of the board, so you can just look at the pinouts and figure out where it goes. But just so you know, the negative goes towards the center this way. So the negative stripe is there, positive is on that side. Also, the other capacitors, there's basically three different capacitors. You got one of those, you got two of those two here on either side of the crystal, then you've got 9 of those. And man, I don't have the schematic in front of me or the instructions. If I remember right, the instructions call for those 9. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. All of those, the instructions, if I remember right, they call for a 0.1 picofarad, but all 9 of them in the kit were 0.33. Now, I assumed that 0.33 would work perfectly fine, just given what they're doing in the circuit. You know, there's probably a broad range that would work. So I assumed they would work, but I was not confident enough in my assumption to solder them all in. So I contacted Eastern Voltage Research. They got back to me right away and said, yep, those are fine. All the kits have been supplied with 0.33, so they'll work perfectly fine. So I soldered those all in. And what else? I think that was it. Now these pads here, that's if you're going to use external switches instead of board-mounted switches. That's these two, for these 2 external switches. And you could just put an external switch in the wire here if you wanted an external switch for that. Those 3 potentiometers, not those 3, I'm sorry. These 2 potentiometers could be external as well. So you're either going to mount the potentiometers to the board or mount them through a connector here. I decided to put it on the board just so I could have it on the top of the box. Same thing with that. I just thought it would be easier to mount them on the board and put a switch extension to the lid of the box instead of routing wires around. Now the speaker is optional. Now this is another thing that I thought was a little bit, I don't want to say off, but could have been improved with the kit. In the instructions, it says that an 8 ohm speaker is recommended, but not required. For $128 or whatever it was, again, I forget exactly, but for 120 plus bucks, they could have included a $1 speaker. I just happen to have a few of those. Now, you don't need it. You don't need it mounted in the box permanently. It's basically just for testing. But what I'm going to do is put another switch on the box. And you'll see that I cut my wire here because I needed to tie in there with the oscilloscope to tune those. I'll get back to that here in a second. So I just left that cut, but I'm going to put a switch in here so I can turn that speaker on or off. So I can turn the speaker on just for testing or whatever if I don't have it connected to the coil, or turn the speaker off when I have it connected to the coil. I did the same thing with my other little interrupter box that I did that you've already seen. But you don't have to have that in there like that, and that can make your box a little bit skinnier. There's also room in here for a 9-volt battery if I wanted to power that with 9 volts. But as it is, I'm just using a generic wall outlet adapter, just a 9-volt wall outlet adapter. But if I ever wanted to, I could put a 9-volt battery in here. But you're going to have limited use for that. You know, this is going to drain that battery down pretty quick. The ICs. Now, the microprocessor came with a socket. So you solder the socket in. And then once you get all the other parts in, you put power on it and you probe out to make sure you have power to the correct pins. Now, it said that if you want to put sockets on the other ICs, it would be a good idea because that would help for troubleshooting and debugging later if you had to pull an IC out. And again, for 128 bucks, they could have included 2 extra sockets, but they did not. Those sockets are like, what, $0.25 each? I had one, so I put it under the opto isolator here. That IC is just driving the output here. I figured if either one of those is going to fail, it would probably be the opto isolator, so I put that on a socket. If I would have had another socket, I would have done one here as well. But, you know, I didn't have one, and I didn't want to wait to order one, so I just went ahead and soldered it in. So again, for the price of this, they could have included the extra sockets. They could have included a speaker. My kit did not come with knobs. Now, I wouldn't have used them anyways because they wouldn't have fit in my lid, so that wasn't a big deal. But the instructions did say put the knobs on, and mine didn't have them. Also, mine didn't even come with the jumpers here. Maybe that's part of the deluxe kit. I don't even know. So I can't really squawk that without reading the description section a little bit better, because maybe those were part of the deluxe kit, and maybe I should have known that if I would have read the instructions better. But anyways, it was a quick, easy build, soldering everything together. With the case, it's all 3D printed, and I made it to where that is not sticking out, because I didn't want that to get bumped or broken, so I recessed that area. You can still screw the, or you can still attach the fiber optic line to that, but that's protected because it's recessed. And there's your MIDI input here. Now, I didn't really like the way that kind of wiggles on the board. So for the lid, I attached a piece of plastic to the lid. So when you put the lid on, that goes kind of around that MIDI connector. And then you put a screw in here, put a screw in here, and that screws into the plastic block I just glued in. And then the other 2 screws just screw in right here. So 4 screws total. 1 here, 1 here, and then the 2 here. And for the LEDs, now this is a translucent material. So you can see the LEDs when they're on, but I went ahead and put some fiber optic rods in there so you can see them right at the top surface when they're on. Completely unnecessary, but I just thought it would look cool. So let me just show you the controls. You have a pulse width mode, you have a frequency mode, and that's raised letters on the 3D print. What I did was I just changed filament color when it got to that point. And by the way, I don't know if I mentioned it yet, but this white material is actually glow in the dark. So that's a glow in the dark material. Doesn't glow as bright as I was hoping it would, but still kind of cool, I think. So let me plug this in, and we'll see if we can hear that speaker. It's not very loud, so I don't know if it's going to pick up on this or not, but we'll try it and see what happens. So this has 4 different modes. When you turn it on, you get the power LED. The other one is MIDI input, and it's flashing now because it's on pulse mode. So I'm going to get a jumper wire and connect that back to the speaker so we can hear it. So that's just normal pulse mode, and you can adjust. I gotta read my lid here. You can adjust the pulse width, which is pretty much just the volume. So turn it down or all the way up, and then you can adjust the frequency here. So that's normal pulse. If you flip this switch to, I think, Alt, that's low frequency mode. So now you got a really low frequency. So that's all the way up. And that's all the way down. I don't know if you can hear that or not. But that's low frequency. And then you have, if you flip this switch up, this is like a burst mode. And what burst mode does is it just puts out a few bursts. They said that'll simulate lightning, maybe. So, I don't know. And then you put that to normal and that to MIDI. And now you can just connect it to a MIDI through a keyboard or whatever that way. Which I've tested. My son has a keyboard upstairs, so I tested that and it works pretty well. I was really hoping to take this out tonight and test it, but it was kind of raining and it got kind of late. And I kind of live in a quiet neighborhood and it's after 9:30, and I don't know. I don't want to be that neighbor. You know, if it was like 8:30, then maybe. But it was kind of raining then, so this will have to wait for another day. And until I get, I had to order some switches. You would think I would have tons of these little switches laying around, but apparently I don't. I couldn't find any. So I ordered a bulk of like 50 of these switches on eBay. So as soon as I get one of those in, I'll probably just mount that switch right to the side or right to the top of the box here. But for now, I'll just leave that wire disconnected until I get that switch in. Now for adjusting these, I didn't record that because what you do is you hook up an oscilloscope here and you put it in MIDI mode and you play the lowest note on the keyboard and you adjust that potentiometer for maximum pulse width. And then you play the highest note and you adjust this one for duty cycle. So maximum pulse width is 300, man, I feel like an idiot, 300 US. Is that milliseconds? Microseconds? Milliseconds, I think. Or nanoseconds. I don't even know. So I was kind of struggling with the oscilloscope because I'm not really proficient with using an oscilloscope. But I finally got the measurement that had what I needed and I made the adjustment. The duty cycle, if I remember right, we set that to 5%. I think that's right. I forget what the instruction said. I set it to what the instruction said. I think it's 5%. I might be misremembering. And then this one over here is setting the pulse width for the pulse mode. Now, the thing where the instructions are lacking there is the instructions didn't tell you how to do that. They told you very clearly, very specifically how to adjust this one, very clearly how to adjust this one, and then they said, oh yeah, that's just to adjust the pulse width and pulse mode. So what I did was I turned it all the way up, and then I adjusted it for the 300 here. I assume that's the right thing to do, but they didn't tell you. It makes sense to me anyways. So you put that in pulse mode, you get it pulsing, turn it all the way up here, and then adjust that one. And so anyways, that's the box. Not the most elegant 3D printed box I've ever made, but it works. It's a little bit chunky, but it works. So as soon as I get a nice evening that's not raining and it's not too dark, we'll take it outside and we'll go through some of these modes. So be back in just a minute. So hopefully when we come back to you, I'll be out in the driveway.